My dear students, good morning. Welcome back to our physics online class. I believe that you have learned the book bag questions for unit 1 and unit 2 whatever I have completed. Okay, we are in the second chapter. Second chapter is kinematics. In this unit, we have learned the concept of rest and motion, different types of motion, linear, rotational, oscillatory, the necessity for reference frame to explain the motion of objects, the meaning of vectors, scalars and their products, the role of scalar and vector products in physics, and the last class we have learned some basics of differentiation and integration. I said to learn some of the important formulas in the differential calculus and integral calculus. In the differential calculus, y equal to x derivative dy by dx equal to 1, y equal to x square dy by dx equal to 2x. Otherwise, generally we can write y equal to x power n means the derivative, this is the differential calculus, dy by dx is equal to n into x power n minus 1. And y equal to sin x dy by dx is cos x and so on. Similarly, for integral calculus, integral of dx, this is a symbol of integration like long s. Integral dx is equal to x d by dx of x is equal to 1. And integration of x power n dx is equal to x power n plus 1 by n plus 1. This is integration, this is differentiation. And integral of 1 by x is equal to log x. Integral of cos theta d theta equal to sin theta. Integral of sin theta d theta equal to minus cos theta, etc. Also, I have discussed average velocity. What is average velocity? Average velocity is defined as the ratio of the displacement vector to the corresponding time interval. Ratio of the displacement vector to the corresponding time interval, that is V average is equal to delta R by delta T. This is a vector quantity. And average speed is equal to total path length divided by total time. Then instantaneous velocity. Instantaneous velocity means at a particular instant, instantaneous velocity at an instant, or simply velocity at an instant time t is defined as the limiting value of the average velocity. Delta t tends to 0, that is v vector equal to limit delta t tends to 0, delta r by delta t equal to dr by dt. Then speed. The magnitude of velocity is called speed. That is v equal to square root of vx square plus vy square plus vz square. Speed is also a positive scalar. The unit of speed is also meter per second. Then momentum. The momentum is the product of mass and velocity. So P equal to mv. The component form we can write px I cap plus py j cap plus pz k cap equal to mvx I cap plus mvy j cap plus mvz k cap. Also, I said to do some of the problems, example problems. I hope you all have completed. Today I am going to teach motion along one dimension. Motion along one dimension. Already we learned motion one dimension, motion two dimensions, motion three dimensions and all. What is motion one dimension? One dimensional motion is the motion of particle moving along a straight line, or we can say rectilinear motion or linear motion. That is, only one of the three rectangular coordinates is specifying the position of the object, either x-axis or y-axis or z-axis. That is one dimension. Two dimension means it is specifying the plane. That is, two of the three coordinate axes are changing with the time. Three dimensions means three coordinates also changes with the time. Okay. Today, motion along one dimension. In this topic, first average velocity. Average velocity. What is average velocity? In the three-dimensional system means we can write the average velocity V average. vector quantity is equal to delta r by delta t. The average velocity is defined as the ratio of the displacement vector to the corresponding time interval. This is in case of 3 dimension. R is a position vector, that is displacement. R vector, how can we write? Xi cap plus yj cap plus zk cap. Okay. Here we are going to learn along one dimension. So if a particle moves in one dimension, say along the x direction, then how can we write the average velocity? The average velocity is equal to delta x by delta t. Only one of the coordinate is equal to, what is delta x? That is x2 minus x1 by t2 minus t1. That is delta t. x2 minus x1 by t2 minus t1. This is also a vector quantity. In case the particle is moving in y direction, we can write delta y by delta t equal to y2 minus y1 by t2 minus t1. Or z direction means delta z by delta t, z2 minus z1 by t2 minus t1. So this average velocity in one dimension. But in one dimension we have two directions, positive and negative directions, positive and negative x directions. Here we use positive and negative directions to denote the directions. Now, instantaneous velocity. Instantaneous velocity, or we can say simply the velocity. What is instantaneous velocity? Instantaneous velocity at an instant is defined as the limiting value of the average velocity. When we write the limiting value of the average velocity, that is equal to the instantaneous velocity, or simply we can write the velocity. So here this can be written as v is equal to limit delta t tends to 0 delta x by delta t. This can be written as dx by dt. In 3 dimension means we can use delta r by delta t. Here only one dimension, so we can write the instantaneous velocity v is equal to limit delta t tends to 0 delta x by delta t equal dx by dt. Okay. Now just to consider the position and time graph. Position and time graph. From this, how can we obtain the velocity? So here, this is the time along the x-axis. This is the position variation along the y-axis. Suppose the variation is like this. Here, how can we obtain the velocity? When we are taking the slope represents delta x by delta t. That is known as velocity, isn't it? So graphically, the slope of the position time graph will give the velocity of the particle. Position time graph, from this, when we are taking the slope, that slope gives the velocity. At the same time, if velocity time graph is given, how can we obtain the distance or displacement? That is, suppose this is the velocity time graph. This is time taken along x-axis, velocity is taken along y-axis. Suppose the graph is like this. So when the velocity time graph is there, how can we obtain the distance or displacement? That is nothing but the particular time interval. That is, this is t1 and t2 means the area under this curve is giving the displacement. Area under the curve will give the displacement travelled by the particle from time t1 to t2. So area under this curve is equal to the displacement. We know that the velocity formula, that is dx by dt is equal to v. From this we can write dx is equal to v into dt. Dx is equal to v into dt. Now by integrating both the sides, we can write integral dx is equal to integral v dt. Integral dx is equal to integral v dt. That is, here I am writing x1, x2. This is the position. Initially it is from the position x1. Now it is after the time this particle reaches the position x2. Here the integration from the time t1 to t2. This is the limit we should apply. This we can say lower limit. This is we can say upper limit. This is the from limit. This is the to limit. From time t1 to t2. This is the process we are writing the integration. So by integrating both the sides, we can write integral dx x1 to x2. Integral x1 to x2 dx is equal to integral t1 to t2 v dt. Because we have seen integration is equal to the area under the curve. Integration is equal to the area under the curve. So integral v dt, velocity time graph, represents the area under the curve. This integration of velocity time represents the area under the curve as a function of time. Since the left hand side of the integration represents the displacement travelled by the particle from time t1 to t2, the area under the velocity time graph will give the displacement of the particle. If the area is negative, it means the displacement is negative. So particles have travelled in the negative direction. The area is positive, displacement is in the positive. So we have seen the average velocity in one dimension. This delta x by delta t. Instantaneous velocity means limiting the average velocity. So v equal dx by dt. When the position time graph is given, we can get the velocity by taking the slope. But when the velocity time graph is given, we have to take the area by getting displacement. Let's see one of the problem related to this concept. Example 2.25. A particle moves along the x-axis in such a way that its coordinate x varies with the time t according to the equation x equal to 2 minus 5t plus 6t square. What is the initial velocity of the particle? A particle moves along the x-axis in such a way that its coordinates x varies with the time t according to the equation x equal to 2 minus 5t plus 6t square. What is the initial velocity of the particle? So the displacement is given. That is position where x is equal to 2 minus 5t plus 6t square. Now initial velocity they asked to calculate. Initial velocity. So what is initial velocity? That is at time t equal to 0. At time t equal to 0, what is the velocity? Velocity can be obtained by v is equal to dx by dt. Dx by dt. So we can write d by dt of 2 minus 5t plus 6t square. 2 minus 5t plus 6t square. That is differentiation. How can we do the differentiation? Differentiation of the constant. It is 0. Next, minus 5 into t. That is in the differentiation. Dx by x is equal to 1. So here dt by dt is equal to 1. So 1 into minus 5. So we can write minus 5 plus differentiation of 6t square. That is 6 into what is t square? X power n equal to n into x power n minus 1. So 2 into x power 2 minus 1. That is 1. So we can write 6 into 2 into t. That is minus 5 plus 12t. Students, listen. The position is given. We have to calculate the velocity. So we have to differentiate dx by dt. So d by dt of this position 2 minus 5t plus 6t square. The position varies along only the x-axis. Here differentiation of this number is 0, the constant. Differentiation of minus 5t, minus 5, differentiation of time with respect to t, that is dt by dt is 1. So minus 5 into 1 minus 5 plus 6t square. Differentiation of x power n, that is n into x power n minus 1. So we can write 2 into t power 2 minus 1. So 6 into 2, that is 6 into 2t. So we can write minus 5 plus 12t. Our question is find the initial velocity. So substitute the value of t equal to 0. So initial velocity means at the time t equal to 0, that is substituting t equal to 0, we will get minus 5. So minus 5 meter per second is the initial velocity by substituting t equal to 0. Here the negative sign implies that the velocity of the particle is along the negative x direction. When we put the time t equal to 0, we got minus 5 meter per second. The negative sign implies that the velocity of the particle is along negative x direction. The next one is relative velocity. Relative velocity. Relative velocity in 1 and 2 dimensional motion. What is meant by relative velocity? When two objects A and B are moving with different velocities, then the velocity of one object A with respect to another object B is called relative velocity of object A with respect to B. What is relative velocity? When two objects A and B are moving with different velocities, then the velocity of one object A with respect to another object B is called the relative velocity of object A with respect to B. That is relative to one another. With respect to A, what is B? With respect to B, what is the velocity of A? That is known as the relative velocity. Let's see some of the special cases in this relative velocity. Case 1. Consider two objects A and B moving with uniform velocities VA and VB. A and B are the two objects moving with the velocities VA and VB along the straight tracks in the same direction. Okay, same direction. So what is the relative velocity? The relative velocity of the object A with respect to object B is VAB equal to VA minus VB. The relative velocity of object A with respect to object B is VAB is equal to VA minus VB. The relative velocity of object B with respect to object A is VBA equal to VB minus VA. VB minus VA. So if two objects are moving in the same direction, the magnitudes of the relative velocity of one object with respect to another object is equal to the difference in magnitudes of the two velocities. Okay, the relative velocity equal to the difference in velocities, difference in magnitude of the two velocities. Let's see the example. Example 2.26. Suppose two cars A and B are moving with uniform velocities with respect to ground along the parallel tracks and in the same direction. Let the velocities of A and B be 35 km per hour due east and 40 km per hour due east respectively. What is the relative velocity of car B with respect to A? So VBA we have to find. Let's see the solution. So what are the given quantities? Velocity of the car A is 35 km per hour and the velocity of the car B due east is 40 km per hour. They are asked to calculate velocity of car B with respect to A. So VBA. What is VBA? VBA is VB minus VA. That is 40 minus 35. That is 5 km per hour due east. Similarly, we can write relative velocity of A with respect to B. VAB. VAB means VA minus VB. What is VA minus VB? That is 35 minus 40. That is minus 5. Minus 5 means we can write 5 km per hour due west. 5 km per hour due west. So to a passenger in the car A, the car B will be appear to be moving in the east with a velocity 5 km per hour. To a passenger in train B or car B, the car A will be appear to move westwards with a velocity of 5 km per hour. Because VBA is plus 5, VAB is minus 5. So first case, the car appears to move in the east direction. Next case, the car appears to move in the west direction. Case 2. Consider two objects A and B moving with uniform velocities VA and VB along the same tracks but opposite direction. First case we have discussed about the same direction. Here the objects A and B moving with uniform velocities VA and VB along the same track but opposite direction. That is VA may be this direction and VB vector in this opposite direction. So what is the relative velocity? The relative velocity of A with respect to B is VAB equal to VA minus VB because VB is traveling opposite direction. So we can write VA minus into minus plus. So VA plus VB. Understand? So VAB is equal to VA plus VB. Similarly, the relative velocity of B with respect to A is, what is that? VBA equal to minus VB minus VA. The velocity of the object B is opposite direction, so we should put minus. Minus VB minus VA can be written as minus of VA plus VB. Thus, if two objects are moving in the opposite directions, the magnitudes of the relative velocity of one object with respect to other is equal to the sum of the magnitudes of their velocities. Okay, when the two objects are moving in the opposite directions, what is the relative velocities? Equal to the sum of the magnitudes of their velocities. Next, case 3. Consider the velocities VA and VB of the two objects at an angle theta. At an angle theta between their directions. How can we write? The relative velocity of A with respect to B can be written as VA minus VB. Then the magnitude and direction of VAB is given by, that is, VAB equal to root of VA square plus VB square minus 2VA VB cos theta. Already we have learned in the triangle law of addition and all this formula. That is, when the two vectors are acting in the same direction, we can add easily. When the two vectors are acting opposite direction, we can subtract easily. But when the two vectors are acting at an angle, we should follow either triangle law of addition or parallelogram addition. Isn't it? The same method only here we are following. Velocity is a vector quantity. So two velocities VA and VB are acting at an angle. What is the relative velocity of A with respect to B? VAB equal to VA minus VB. That is, the magnitude of VAB is given by root of VA square plus VB square minus 2 VA VB cos theta. Also the direction. The direction we can write in terms of tan theta. That is here tan beta. Beta is another one angle. So we can write VB sin theta divided by VA minus VB cos theta. Beta is the angle between VAB and VB. VAB and VB. If you learn triangle law of addition, this is very easy. So what is alpha there? B sin theta by A plus B cos theta. Likewise here, tan beta, the direction of the relative velocity is equal to VB sin theta by VA minus VB cos theta. Beta is angle between VAB and VB. In this formula, let's see some of the special cases. First one, when theta equal to 0. That is, the body is moving along the parallel straight line in the same direction. Same direction, theta equal to 0. And theta equal to 0, what is cos 0? Cos 0 is 1. So, VAB can be written as root of VA square plus VB square minus 2VA VB into 1. So, this can be written as A square plus B square minus 2AB. That is nothing but VA minus VB the whole square. Square root of VA minus VB the whole square. So, we can write VA minus VB. So, VAB is equal to what? VA minus VB. This is the first point we have learned. Similarly, the relative velocity VBA means how can we write? Root of VB square plus VA square minus 2 VA VB cos theta. So, here we can write VBA is VB minus VA. VB minus VA. Second case. When theta is equal to 180 degree. When theta is equal to 180 degree, that is the body is moving in the opposite direction. So we have VAB is equal to, what is cos 180? Cos 180 is minus 1. So when you are substituting here, VAB is equal to VA square plus VB square minus 2a VB into cos 180 is minus 1. So we can write root of VA square plus VB square minus into minus plus 2VA VB. So we can write VA plus VB the whole square root of VA plus VB the whole square, or we can write VA plus VB. So VAB is equal to VA plus VB, which is in the direction of A. Similarly, VBA can be written as VB plus VA. VB plus VA, that is in the direction of VB. So when theta equal to 0 degree, VAB equal to VA minus VB. Here VAB is in the direction of VA. VBA is VB minus VA. That is, the VBA is in the direction of VB. When theta equal to 180 degree, that is opposite direction, VAB is VA plus VB. That is, VAB is in the direction of VA, and VBA is VB plus VA. That is, VBA is in the direction of VB. Next case, when theta equal to 90 degree. What is cos 90? Cos 90 is 0. So what is the term? VAB is equal to root of VA square plus VB square minus 2 VAB. Cos 90 is 0. So we will be getting root of VA square plus VB square. This is VAB. So the magnitude of the relative velocity of A with respect to B is square root of VA square plus VB square. Consider a person moving horizontally with velocity Vm. That is, Vm is the man velocity. Velocity of man. And we can consider the rainfall. Rainfall vertically with velocity Vr. So Vr be the rain velocity. Velocity of the rain. An umbrella is held to avoid the rain. So what is the relative velocity of the rain with respect to person? Rain with respect to man. That is VR minus Vm. VR minus Vm. So we can write the magnitude as Vrm is equal to root of Vr square plus Vm square. Since the person, that is the person is walking horizontally and he is holding the umbrella, that is vertically. So the angle between the axis is between these two, the umbrella, the rain direction, and the person moving in the direction. The angle is 90 degree. So cos 90 is equal to 0. So we will be getting Vrm equal to root of Vr square plus Vm square. Similarly, the direction theta can be written as tan inverse of Vm by Vr. Tan inverse of Vm by Vr. This is the rain velocity Vr, and this is the man velocity Vm. Okay. So velocity of rain with respect to man. So this is the relative velocity Vr. This is the angle theta. Okay. So this is minus Vm, this is Vr, this is theta. So this theta can be written as tan inverse of Vm by Vr. Now to save himself from the rain, he should hold an umbrella at an angle theta with the vertical. Okay. So students, we have learned about the relative velocity in 1 and 2 dimensional motion. That is the velocity of object A with respect to B. Case 1, when the two objects are moving in the same direction, the relative velocity can be written as VAB equal to VA minus VB or VBA equal to VB minus VA. Then case 2, VA and VB opposite direction means the relative velocity VAB equal to VA plus VB and VBA equal to minus of VA plus VB. In case 3, at an angle theta means We have the magnitude VAB equal to root of VA square plus VB square minus 2 VA VB cos theta, and the direction tan beta equal to VP sin theta by VA minus VB cos theta, where beta is the angle between VAB and VB. Then when theta equal to 0, VAB equal to VA minus VB. When theta equal to 180, VAB equal to VA plus VB. Theta equal to 90 degree, VAB equal to root of VA square plus VB square. Students, you have to do the problems. Example 2.27, 2.28, 2.29, 2.30. All the problems are easy problems. Okay. Related to this relative velocity topic. 2.27, 2.28, 2.29 and 2.30. The next one is accelerated motion. Accelerated motion. What is meant by acceleration? We will write A equal to dv by dt. Rate of change of velocity is equal to acceleration. Isn't it? It is also a vector quantity. So, the velocity of the object is no more constant but changes with the time. The velocity of the object is no more constant, not constant, but changes with the time. Such a motion is said to be an accelerated motion. So during non-uniform motion of an object, the velocity of the object changes from instant to instant. In this accelerated motion, if the change in velocity per unit time is constant or same, then the object is said to be uniformly accelerated motion. What is that? If the change in velocity per unit time is constant. For every time interval, the change in velocity is constant. If the change in velocity per unit time is same or constant, then the object is said to be moving with uniformly accelerated motion. On the other hand, if the change in velocity per unit time is different at different times, then the object is said to be moving with a non-uniform accelerated motion. So, two types, uniformly accelerated motion and non-uniform accelerated motion. Okay. Next one, average acceleration, like average velocity. Okay, if the object is moving with velocity v1 and after some time it changes the velocity v2 in a time interval t1 to t2, then what is the acceleration? The average acceleration is defined as the ratio of change in velocity over the time interval. Ratio of change in velocity over the time interval. So we can write, acceleration, average acceleration is equal to v2 minus v1 divided by t2 minus t1, can be written as delta v by delta t. So if an object changes its velocity from v1 to v2 in a time interval t1 to t2, then the average acceleration A is equal to v2 minus v1 by t2 minus t1, that is equal to delta v by delta t. This is also a vector quantity. Similarly, instantaneous acceleration. What is instantaneous acceleration? Instantaneous acceleration, or simply the acceleration of a particle at a time t, is given by the ratio of change in velocity over delta t as delta t approaches 0. That is, average acceleration will give the change in velocity over the time interval, entire time interval. It will not give the value of the acceleration at any instant time. But instantaneous acceleration, that is acceleration of a particle at time t, is given by the ratio of change in velocity over delta t as delta t approaches to 0. So, A equal to limit delta t tends to 0 delta v by delta t, that can be written as dv by dt. Same what we have learned, the average velocity and instantaneous velocity. So, instantaneous acceleration means limiting the average velocity. So, acceleration at a particular time instant t is equal to the rate of change of velocity. It is also a vector quantity. What is the unit of acceleration? Meter second raised to minus. What is the dimensional formula? M power 0, L power 1, T power minus 2. Acceleration is positive if the velocity is increasing, and it is negative if the velocity is decreasing. Okay? That is, if the velocity is increasing, acceleration is said to be positive. If the velocity is decreasing, acceleration is said to be negative. The negative acceleration is called a retardation. Negative acceleration is called the retardation, or we can say deceleration. In terms of components, we can write acceleration is equal to dvx by dt I cap plus dvy by dt j cap plus dvz by dt k cap. So, ax is equal to dvx by dt, ay is equal to dvy by dt, and az is equal to dvz by dt are the components of instantaneous acceleration. Okay, students, today we have discussed about motion along one dimension. In that, average velocity we have learnt, and relative velocity in 1 and 2 dimensional motion. Then we have discussed about the accelerated motion, uniform accelerated motion, non-uniform accelerated motion, average acceleration, instantaneous acceleration. So, you have to learn relative velocity in 1 and 2 dimensional motion, all the special cases. Then you should do the problems 2.27, 28, 29, 30. Also learn the definition of average acceleration, instantaneous acceleration. Thank you, students.